I have to show that 3 to the power 2n minus 1 is divisible by 8 for n greater than 1, any greater 1 and greater than 1 for any n. That is for all integers, basically all positive integers. So I have to use mathematical induction to do that. And in order to do that, first I will do, since this is greater than equals to 1, the first integer is n is equal to 1. I will see whether I can show that this one is divisible by 8. So when n is equal to 1, this one becomes 3. So that's 9 minus 1 is equal to 8, which is divisible by 8. So that's there. Then we make an assumption that this one is divisible by 8 when n is equal to k. So if it is divisible by 8, we can write it as 8p, where p is an integer. P is just another integer we are introducing. So if it is 8p, that means whatever the value of p is, 8 times p, it will be divisible by 8. So we are assuming that it is divisible by 8, and we are assuming that this one is equal to 8p. So now we will see what happens when n is equal to k plus 1, and when that happens, this becomes 2k plus 1 minus 1, so that's 3 2k plus 2 minus 1, which is 3 2 to the power k times 3 square minus 1, which is 9 3 to the power 2k minus 1. Now what we could do from here, from this one, this one can be written 3k is equal to 8p plus 1. So instead of 3 to the power 2k, we can write 8p plus 1. So this one is 9, and 8p plus 1, instead of 3 to the power 2k, I am writing that minus 1. So it becomes 72p, I am multiplying, getting rid of the bracket, plus 9 minus 1. So that's 72p plus 8. So if I take 8 out, it will be 9p plus 1. So this one is what we are getting, and this one is whatever the value of p is, this one is divisible by 8. So we have shown that when n is equal to k plus 1, the 3 to the power 2n minus 1 is divisible by 8. So it's proved by mathematical induction that 3 to the power 2n minus 1 is divisible by 8.